Now we are going to discuss about bitwise NOT operators. This is one of the operators in Python, which is a confusing one. So I'm going to take you through an example. First of all, the operator is the tilde operator. This is how you represent a bitwise NOT operator in Python. And so say I'm going to have a variable called a and going to store 10 inside it. Now we're going to perform this bitwise NOT operator on a, and the resulting value would be minus 11. So let us see in detail and on how this is returning minus 11. First of all, we know that any bitwise operator would perform the calculation on bits of that integer. So the integers would get converted into binary format, and then the calculation is performed on them. So the binary representation of 10 would be 1010, and since this is the positive number, you also have something called sign bit in the beginning, which would be represented as either 0 or 1 based on what kind of number it is. So since 10 is a positive number, the sign bit would be 0 in the beginning. All right. And then we're going to perform the NOT on 10. So initially what would happen is it would get converted into, it would just reverse the numbers. So you have 10 in here. So 0 would become 1 and 1 would become 0. And then 0 would become 1 again. And then 1 would become 0 again. Okay, so this is the first step that it is gonna do. And when you perform an NOT operator, it's also gonna convert the bit, the sign bit in the beginning. So since it is 0 here, it's gonna convert it into 1. That would make it as a negative number here. Got it? So this is the first step that it is gonna perform. Now, if you convert, so the resulting value gonna be in the decimal format after performing the calculations on the binary. Now the decimal format of this would be 0101. That would be 5, I guess. So 101. So how could you convert a binary number into a decimal number is by performing 2 to the power 0. So multiplying 1 with 2 to the power 0 and multiplying 0 with 2 to the power 1. So let me write it down here. So this is the bit and multiplied by 2 to the power 0, 1, 2, 3. And then plus 1 multiplied by 2 to the power 2 plus 0 multiplied by 2 to the power 1 plus 1 multiplied by 2 to the power 0. So that would be, so output of this would be 1 and this would be 0, 1 plus, and this would be 2 to the power is 2, which is 4. 4 times 1 is 4. And then this would be 0. So this is 0 plus 4 plus 0 plus 1. That would be 5. So the decimal format of this is gonna be 5. But we have got an answer as minus 11. And we know this minus is indicated by this sign bit in the beginning. So it's obviously gonna be a negative number when you're performing a bitwise NOT on a positive integer. Now, how would this get converted into 11 again? Now, what the next step we're gonna do is we're gonna perform 1's complement of this number, which means we're gonna reverse this number just like how we did before. So that is gonna be as, so this is still gonna be 1. We're not gonna perform that on the sign bit, and then 0 would get converted into 1, and then 1 gonna get converted into 0, 0 again gonna get converted to 1, and this one gonna become 0 again. Now this is the 1's complement. And then we need to perform something called 2's complement on 1's complement. So that is nothing but adding 1 to this. So I'm gonna add 1 to this. So you know, right, when you perform addition operation on bits, how would that work is, so 0 plus 1 would become 1, and at least one of the operators has to be, one of the bits has to be 1 in order to return 1. So this addition of that would be 1, 0, 1, and 1. Now the decimal value of this number would be would be 11, and we could just do it like how we did earlier. So 2 to the 0 1 times 2 to the power 3, just like how we did here, but just gonna convert change the bits. So this is the second bit, which is 0 here, and this is 1, and this is 1 as well. So now this resulting value would be, this is 1, 1 plus 2 plus 0 plus 2 to the power 3 is 8. 8 times 1 is 8. So 8 plus 0 plus 2 plus 1 would give you 11. And that's how you're gonna get the output value as 11. And since you're gonna have your sign bit is 1 in the beginning, it's gonna become minus 11. So that's how you're getting minus 11 when you're performing a bitwise NOT operator on the value 10, on the binary number 10. And so let me quickly recap, take you a recap of what happened now. So first of all, you're gonna convert the decimal number into binary. So that would give you this format. You should make sure you're including the sign bit as well. And then you will have to reverse that number in order to apply this NOT operator. So this NOT is nothing but technically reversing it. So if you have 0, it would become 1. And if you have 1, it's going to become 0. So that's what happened in here. And that's not how it's going to end. You will have to perform 1's complement to the converted number. So you're going to perform 1's complement to this number, and you're going to get this. 1's complement is nothing but again reversing it back. That would become 1010. This time we are not going to apply that to the sign bit. Sign bit only would change when you are applying the NOT operator. Here we are not doing that. And then performing 2's complement, which is nothing but adding 1 to the resulting value of 2's complement, and then the final resultant binary number would get converted back to decimal along with the minus sign. That's how you get the answer as minus 11. So with this, I'm going to end this video. We'll see you in the next video with a different topic.